Hello, welcome to Astronautics for Exploit. This is Dr. Ayanshola Ogundele. Interplanetary space exploration, catalyst for new celestial bodies discovery and future exploration augmentation. The focus points are as follows: interplanetary space, reasons for exploring interplanetary space exploration, and interplanetary space achievements. Exploration of interplanetary space, a vast expanse of space between the planets in the solar system, has been desired by humanity for centuries based on its importance to humanity and the abundant and untapped natural resources. Interplanetary space is forecasted to be a future laboratory for scientific research. Through the exploration of interplanetary space via spacecraft and robotic, various important information about the planets, moons, asteroids, and comets composition, structure, and their environmental phenomena have been discovered. The scientific and commercial reasons behind interplanetary space exploration are expansion of human's knowledge of the universe, discovery of new celestial bodies, planetary formation and evolution, search for signs of life, and preparation for future human space exploration activities. For the exploration of interplanetary space, several missions have been undertaken and are being undertaken, such as Sojourner, Spirit, Opportunity, and Curiosity, which have provided valuable data about the red planet's geology and potential for past or present life. Voyager 1 and Voyager 2, launched in 1977, have transferred through interplanetary space and have enabled humans to gather insights into the boundary where sun's influence ends and interstellar space begins. Interplanetary space. The space between the planets is the space filled with the solar wind, the interplanetary magnetic field, the cosmic rays and dust, and it is referred to as the interplanetary space. Interplanetary space is also referred to as heliosphere because the space between the planets is the total space which is under the influence of the sun. Artists' impression of starship designed for interplanetary missions cruising past the moon is shown in this picture. Interplanetary space, the region between celestial bodies, is an expansive and largely uncharted territory with countless planets, moons, asteroids, and comets inhabiting this vast expanse, and there is still so much to discover. The average temperature of the interplanetary space hovers around 270 degrees Celsius, and as at present is inhospitable for life. Concept for a deep space transport spacecraft that will take astronauts to and from Mars is shown in this picture. Solar wind, a constant outflow of charged particles from the sun, has a profound impact on the structure and dynamics of interplanetary space. This phenomenon creates magnetic fields and shapes the trajectories of objects within the space. Interplanetary space contains sparse particles known as interplanetary dust, which can pose challenges to spacecraft and can cause fascinating phenomena like zodiacal light. Illustration of nuclear technology for future space missions is shown in this picture. Successfully reaching destination in interplanetary space requires meticulous calculations of trajectories. Due to the gravitational pull of various celestial bodies, spacecraft must navigate complex paths to optimize fuel efficiency and reach their desired destinations. Interplanetary space serves as an excellent laboratory for scientific research. Robotic spacecraft and telescopes can capture invaluable data about the composition, structure, and phenomena occurring within the unique environment. Studying interplanetary space provides valuable insights into the formation and evolution of the solar system. By examining the composition of asteroids, comets, and other interplanetary objects, scientists can piece together the puzzle of the cosmic history. Interplanetary dust particles present in space occasionally make their way to Earth's atmosphere. These microscopic particles contribute to the occurrence of meteor showers and can provide scientists with information about the composition of celestial bodies. Illustration of the cislunar autonomous positioning system technology is shown in this picture. There are various reasons for interplanetary space exploration. The exploration of interplanetary space offers a lot of advantages, such as expansion of human's knowledge of the universe, discovery of new celestial bodies, study of planetary formation and evolution, search for signs of life, and preparation for future human space exploration. Interplanetary space exploration provides valuable insights into Earth's history and Earth's events to understand Earth's place in the universe. Orion and European service model orbiting the Moon is shown in this picture. Presently, various low Earth orbit, geostationary Earth orbit, and interplanetary space missions are serving as source of inspiration to the kids all over the world. Efforts are underway to extract rare earth elements which can be found as close by as the Moon, helium-3 used for some specific MRIs, and the potential fuel for nuclear power plants. NASA's Orion spacecraft planned to take astronauts from Earth to the Moon is shown in this picture. Interplanetary space exploration. Interplanetary travel is a longer period endeavor which requires several years to reach distant destinations. The vast distances and limited propulsion capabilities of current spacecraft mean that patience and careful planning are essential for successful missions. Exploratory missions to interplanetary space involve equipping spacecraft with various instruments and experiments. These tools are designed to study the environment, collect samples, analyze radiation, and investigate the potential for extraterrestrial life. An illustration of the twin gray spacecraft mapping the moon gravity field is shown in this picture. The sun's influence extends far beyond Earth's atmosphere. The solar wind and solar radiation have a significant impact on interplanetary space, shaping and influencing the behavior of spacecraft within this region. Several landers and rovers have successfully touched down on interplanetary services. For example, Mars rovers such as Sojourner, Spirit, Opportunity, and Curiosity have provided valuable data about the rare planet's geology and potential for the presence of life. Artist's concept of Juno spacecraft in orbit is shown in this picture. Interplanetary voyages have taken spacecraft to the outskirts of our solar system. Voyager 1 and Voyager 2, launched in 1977, have reached interstellar space, allowing us to gather insights into the boundary where our sun's influence ends and interstellar space begins. Marvin, Mars' atmospheric and volatile evolution and in orbit is shown in this picture. Due to the vast distances involved, communication between spacecraft and Earth across interplanetary space relies on radio waves. These signals travel at the speed of light, enabling scientists and mission controllers to receive data and commands from far-off exploratory missions. Space debris, including spent rocket stages and defunct satellites, pose risks to interplanetary missions. These objects orbiting the Sun can intersect with the trajectory of spacecraft and cause collisions or damage via their equipment. Artist's concept of NASA's New Horizons mission is shown in this picture. Interplanetary space serves as a potential frontier for future human exploration. With advances in technology, missions to neighboring planets like Mars could become a reality, paving the way for human habitation and further exploration. The exploration and study of interplanetary space are crucial for expanding our knowledge of the universe. By unraveling its secrets and pushing the boundaries of our understanding, we gain insights that can shape future scientific breakthroughs and advancements. Voyager interstellar mission designed to conduct close-up studies of Jupiter and Saturn Saturn rings and the larger moons of the two planets is shown in this picture. Interplanetary space achievements. Majorly, interplanetary space exploration has been conducted using robotic spacecraft because of the harsh environment of the interplanetary space. The various interplanetary space missions undertook explore planets, comets, and various parts of the solar system. Illustration of Stardust spacecraft mission is shown in this picture. Examples of interplanetary space missions are Voyager 1 and 2, Pioneer 10, Cassini-Huygens mission, and Stardust. Interplanetary space missions have enriched human knowledge about the solar system composition. The technology originally designed for interplanetary space exploration are being used on Earth to develop various space spin-offs for the benefits of humankind. MAVEN, Mars Atmospheric and Volatile Evolution, and Interplanetary Space Exploration Mission, critical measurements of the marine atmosphere to help understand dramatic climate change on the red planet is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Interplanetary Space Exploration Catalyst for New Celestial Bodies Discovery and Future Exploration and Augmentation, presented by Dr. Ayoshola Ogunele, with the focus points: interplanetary space, reasons for exploring interplanetary space, interplanetary space exploration, and interplanetary space achievements. Thank you.